Hello everybody. So here we are going to do a very important question from Olympiad's point of view, that is called Wavy Curve Method. It's a method to solve inequalities. So let's start with it. So before actually starting with Wavy Curve Method, we need to understand some of the things in linear inequalities first before actually going on to the higher things, right? So for example, there is something called interval notation, right? Interval notation, which you need to be clear with. Then only you can proceed with it, right? So for example, if you have got something like this, x is greater than equal to 1 and suppose less than 3, right? X is greater than equal to 1, less than 3. X is a variable which can take all the values between 1 and 3, including 1, but excluding 3 because it is equal to over here and over here it's not equal to. So how can we represent it, guys? We can say x belongs to, this means belongs to, right? This stands for belongs to, it is Greek letter epsilon, right? Closed interval 1 because it is included from closed interval 1 to open interval 3. So whenever you use square bracket, it means you are including the boundary value, and when you are using round bracket, it means you are excluding the boundary value. And if you want to show the same thing on the number line, it can be done like this. You can take all the values from 1 to 3 like this. Now you see 1 is to be included. So we will color this hole, we will fill this hole. But this cannot be filled because 3 is excluded over here. Correct? 3 is excluded over here. I hope you understand what is the meaning of closed interval and open interval. When the boundary value is to be included, is to be taken, you have to use square bracket, and when the boundary value is not to be taken, is to be excluded, so you have to use round bracket in that case. Correct? But sometimes you can get a situation like this. For example, if I take x is greater than equal to 3, right? If you want to show the same thing on the number line, how will it look like? You see it's 3, so all the values starting from 3, and 3 is to be included because that is equal to 3 as well. You see this. But till when it is going, till what it's going, we don't know that. So it's going on till infinity. So what we can say, x belongs to closed interval 3 till infinity. And you see infinity can never be included. You know, something is never, anything is never equal to infinity. We are just saying that it is approaching towards it. So from 3 to infinity, we can write over here. Right? Suppose if they are saying that x is less than 5, suppose. So how will you show it on the number line? It is something like this. You have got 5 over here, 5, and you don't know till what it is going. And you cannot fill this hole because it is only x less than 5. So 5 is not to be included. Now you see interval notation is every time written from left to right, right? So you can say the values, they are starting from minus infinity till 5, which is not included, and infinity can never be included. So this is the complete presentation of the same thing. So I hope you understand interval notation over here. That's very important because then only, inequalities can be done. Now, for example, we take a linear inequality. Suppose a very simple one. For example, 2x plus 1, it is greater than equal to 7. So if you solve it easily, you can say x is greater than equal to 3. So you can easily say that x belongs to closed interval 3 to infinity. That's correct, right? And if you want to show the same thing on the number line, it will be like this. You start with 3 over here, closed interval 3 to infinity. Something like this. Correct? Fine. But suppose if I give you a question like this, a very simple one. For example, something like this, what will happen? So you might say that minus x is less than 1. So x is less than minus 1. That will be wrong to say that. If you say something like that, it is wrong. Because the moment you multiply or divide by a negative number, inequality will change. So I'm getting minus x is less than 1 means x is greater than minus 1. So you can say that this is x belongs to open interval minus 1 to infinity, right? And if you want to show it on the number line, it will be what? You see minus 1, you're starting with it and going on till infinity. So like this, we can represent this situation. Now you might ask why? That's a simple thing. For example, you see, you know that minus 3 is less than minus 2. If I multiply by minus 1 on both the sides, will you say that 3 is less than 2? No. So the moment you multiply by a negative number, you will say 3 is greater than 2. Is that clear? The moment you multiply by a negative number or divide by a negative number on both the sides, inequality will change. So that's a small thing which you need to understand in inequations, in linear inequations or in any type of inequation, that if you multiply by a negative number or divide by, because you know multiplication and division, it's the same thing. Division is nothing but multiplication by the reciprocal of a number. I hope you know that, right? So whether you multiply or divide by the negative number, inequality will be changed. Now that was a linear inequation. So that was very easy to understand, very simple to do, right? But every time you'll not get something like that. Sometimes you'll get quadratic inequalities and inequalities of more power, more higher exponent as well. So for that only we study something called the Wavy Curve method. So I'll explain using 3-4 questions. Let's see that till how many examples I can take. So for example, you have got something like this, x minus 1 and then x plus 2, and I want to do less than 0. Something like this. So whenever you start with inequalities using Wavy Curve method, two things you have to make sure. First thing is coefficient of the variable must be positive. So two things you have to ensure, that coefficient of the variable is positive. That is the first thing. Second thing is what? You have to ensure that RHS is equal to 0. If it is not 0, you have to make that. So coefficient of the variable is positive and RHS is equal to 0. That you have to do every time. So over here, that's a direct case. Coefficient of the variable, you see that's positive, multiplied by x1 in both the cases, and the RHS is 0 only. So how will I do? Draw the number line, then plot the zeros of the polynomial. What are the zeros of this polynomial? You see, minus 2 and 1. These are the zeros, correct? Now, we have ensured that coefficient of x is positive in the cases. So from here, this region will start with positive. Why I am starting with positive means, if I take any value of x from 1 till infinity, the value of the variable, this expression is going to be positive only. You can check it. You put any value of x which is greater than 1. Suppose if I put x is equal to 2. So 2 minus 1 and then you see 2 plus 2. Isn't it a positive value? Yes, that's a positive value. So any value of x which you will put which is greater than 1, the value of this expression is going to be positive. So again I will explain. First thing is, make sure that the coefficient of variable is positive. First thing. So over here, coefficient of the variable x is positive. Second thing is, make sure that RHS is 0. Over here, RHS is 0 only. Right hand side is 0. Then what will you do? Draw the number line, plot the zeros of each of the polynomials. So 0 of this polynomial is, how will you find the 0? You know that. You will put x minus 1 is equal to 0. So you'll get x is equal to 1. So that is the 0 of this polynomial, right? And the 0 of this polynomial is minus 2. You obviously write it on the number line as you will write it on the number line. Then start with plus, and I had explained what is the meaning of this plus. Then you see, you have to see the exponents of these polynomials. When there is odd exponent, from plus, this sign will change. From minus, this sign will change. When there is odd exponent, sign will change. When there is even exponent, sign will not change. Correct? Now, this is minus and we want the solution for this only. We want this whole polynomial or this expression to be less than 0. So, this region is the solution. It means the solution is x belongs to minus 2 to 1. The solution for this inequality is what? X belongs to minus 2 to 1. That is the solution. I hope it's clear. Okay. So, I'll take other examples as well. See this. For example, I am taking x plus 1 the whole square, x minus 4 the whole cube, x minus 3. Okay. Greater than 0 or greater than equal to 0. Suppose something like this. Okay. So, what will I have to do? First thing is make sure that the coefficient of x is positive in all the cases. So, you can see easily that the coefficient of x is positive in all these cases. So, you don't have to bother about anything, right? So, what will I do? I will plot the zeros of each of these polynomials. 0 of this is minus 1, 0 of this is 3, 0 of this is 4. So, that is 3 and this is 4. Now, as I did say that coefficient of x is positive in all the cases, start with plus sign. Now, this is the 0 of this polynomial having odd exponent. So, sign will change from plus to minus. Now, this is the 0 of this polynomial having even exponent, odd exponent only. So, sign will change from minus to plus, correct? Now, this is the 0 of this polynomial having even exponent. So, sign will not change from plus to plus only. It will not change. Now, we want the solution for greater than equal to 0. So, you see this thing will come up and this thing will come up. I hope you understand. So, from minus infinity, so I will say like this, x belongs to minus infinity to 3. You see 3 can be included as well. Why it can be included? Because you see that is equal to 0 as well. If you take x is equal to 3 in the left hand side, it is the 0 of this polynomial. So, it will make the whole expression 0. So, therefore, 3 has to be included. Union, you see union, because we have to include that as well. You have got plus over here. It means all the values of x which are greater than or equal to 4 will make this expression positive, right? So, included 4, closed interval 4 to infinity. So, that is the solution. Because you see 4 can also be included because it is the 0 of this polynomial. If you put x is equal to 4 over here, that will make this expression 0 over here as well. I hope that is clear, guys. So, that's how you will do it in wavy curve method. Now, let's do more questions on it. These were very simple questions, right? Suppose I'll make it a bit more twisted. See this thing. Oh, why I'm writing 1 every time? Fine. Or maybe greater than equal to 0. It's all up to you. It's not an issue. Suppose it is something like this. We want to solve this inequality. Fine. What is the first thing? You have to make sure that coefficient of x is positive in all these cases. So, you see in this question, coefficient of x is not positive in this case. So, what will I do? See, I'll explain those things, but you don't have to write it every time, but I'll explain the logic. You see from here, if you take minus 1 as common, you'll get x minus 2 over here. And then if you're cubing it, you see minus 1 cube is minus 1 only. So basically minus 1 is hidden there. So basically it is x minus 1 the whole square, and this is x minus 2 the whole cube, and in the denominator it is x plus 2 raised to the power 2025 over here, and then this is x raised to the power 4. I hope that is clear. But you see, we want to get rid of this minus 1, which is written over there. I'm not writing it although. So maybe I will write. So I want to get rid of this minus 1. How will I do that? I'll multiply by minus 1 on both the sides. So this will become plus 1, because minus 1 into minus 1 is plus 1, and over here 0 into minus 1 is 0. But the moment you multiply by a negative number, you know what will happen? Inequality will change. Correct? Inequality will change. Correct? So now you can proceed like the previous question. What will you do? Plot the zeros of all of these polynomials. 0 of this is 1, of this is 2, of this is minus 2, of this is 0. So minus 2, 0, then 0 of this polynomial is 1, 0 of this polynomial is 2. Now you see we made sure that the coefficient of x is positive in all of these cases. You can start with plus sign. Correct? Now you see this is the 0 of this polynomial having odd exponent, sign will change. Then this is the 0 of this polynomial having even exponent, sign will not change, from minus to minus only. Then this is the 0 of this polynomial having even exponent. So sign will not change, from minus to minus only. Then this is the 0 of this polynomial having odd exponent. Sign will change, minus to plus. So you see, we want for less than equal to 0. So this region will be the answer. Less than equal to 0 means negative. It means if you take any value in this region from minus 2 to 2, the value of this expression will be negative only, like I was explaining in this example using this thing, right? So therefore the solution will be what? X belongs to. Now you have to be vigilant over here. Why I'm saying that? You see over here, you just can't keep your eyes closed and take all the values over here, because that might make your answer wrong. Why? Because you see, 0 of the denominator cannot be included, because I cannot put x is equal to minus 2 and x is equal to 0 over here. That will make the denominator 0, and division by 0 is not possible. So minus 2 can't be taken. So open interval minus 2. Similarly, 0 can't be taken. So till 0, you have to break the interval. Union, you see 0. But you see 1 can be taken, because x is equal to 1 will make this expression 0, which is possible because it is equal to 0 as well. So 1 can be taken. Similarly, 2 can also be taken. So 0 to 2, closed interval. So this is the solution over here. I hope that is clear, guys. So that's how wavy curve method works actually. Now sometimes you get a different question over here. I'll take an example. There can be many questions on it, and obviously they will put many other types of functions in that case. They will put many types of functions as well. They will put, when you do trigonometric functions and all that, greatest integer function and all that. I'm just taking simple algebraic functions over here. So for example, if I take something like this, something like this. You have got something like this. So many a times they will give you this type of expression just to scare you out, right? I hope you will understand this logic, what I'm saying. Basically, you see this logic I'll explain because you already know this, but I'll explain this one that, oh my God, you've got a quadratic polynomial raised to the power this much. How I will do that? So you see this, when you see this polynomial x square plus 2x plus 3, x square plus 2x plus 3, if you see this quadratic polynomial, you see coefficient of x square is 1. If you compare it with the standard form of a quadratic polynomial, that is ax square plus bx plus c, coefficient of x square is 1, which is a is greater than 0, right? And if you want to find the discriminant of this quadratic polynomial, discriminant is what? B square minus 4ac. So isn't it 2 square minus 4a is what over here? 1. And c is the constant term. So this is basically 4 minus 12 minus 8, which is less than 0. So discriminant over here is negative. So what does it mean? Coefficient of x square is positive and discriminant is negative. So if you will draw its graph, you know how to draw the graph of a quadratic polynomial. When the coefficient of x square is positive and graph is discriminant is negative, the graph is, I'm not drawing the exact graph, I hope you understand, that's just a simple graph over here. The graph will be above x-axis, something like this. So what does it mean? If you take any value of x over here, the value of the polynomial is going to be positive only. So therefore, the value of this is positive every time, irrespective of the value of x. The value of this is positive every time, irrespective of the value of x. So what does it mean? It means that this is just like any positive number. So it will not contribute in the sign change of the expression. You understand this? It will not contribute, the value of this expression will not contribute in the sign change of this expression. So what we can do, we can just ignore it. It's just like any other number, like 5, 6, 7, 100, any positive number. So it will not contribute in the sign change. So it is negligible. You can just neglect it. You don't need to use it while solving this inequality, right? So that's the first thing, neglect it. Then you have to make sure that coefficient of x is positive in all the cases. It is not positive in this case. So it is exactly like this question, you see, minus. So if you will take negative as common, you'll get something like this. So in order to remove this negative sign, it means in order to remove this negative sign, I'll have to multiply by minus 1 on both the sides. Then inequality will change. So this whole expression will convert to what? X minus 1 the whole square, and then I'll get x minus 2 the whole cube. And then you see this is negligible, and in the denominator it is x plus 4 raised to the power 5. Inequality will change, less than equal to 0. I hope that is clear. And so on. And then you know how to do it. Just plot the zeros of all the polynomials. The 0 of this is minus 4, 0 of this is 1, 0 of this is 2. Then because coefficient of x is positive in all the cases, start with plus sign. Then this is the 0 of this polynomial having odd exponent, so sign will change. Then this is the 0 of this polynomial having even exponent, sign will not change, from minus to minus only. Then this is the 0 of this polynomial having odd exponent, sign will change from minus to plus. So we want for less than 0, so this region is the answer. Now you have to be very careful that which value is to be included and which is not to be included. For example, x is equal to minus 4 can't be included because it is the 0 of the denominator. It will make the denominator 0, and denominator can't be 0 because division by 0 is not possible. So therefore it is to be excluded, so minus 4. But you see 1 can be taken, it is the 0 of the numerator, 2 can be taken, 0 of the numerator. So minus 4 to 2 but closed interval. This is the answer. You can obviously check, but I was just explaining the complete logic to you over here. The complete logic is this. Now suppose one more type, sometimes they can give you this one. Suppose for example, suppose something like this, okay? So very simple question, but I'll tell you why I have given this. See this, even, yeah, you will get some answer only, it's correct, no problem in it. Now you see one thing over here guys, how will you do this type of question? Never ever cancel out common factors. In inequality, never ever cancel out, especially, you know, if number is there, you can cancel it out. For example, if they give you something like this, positive number, just a small example, then you can easily cancel out, no problem in that. There is no problem in it, right? Right? But suppose it's a variable, so don't cancel it out. Even in an equation, don't cancel out because you might miss out some values, and in an inequality that could be it could have a drastic effect on your solution, right? So what you have to do, first thing is make sure that everything on the right hand side is 0. I did write that as well. RHS is equal to 0, right? So what you will do, just take it in the RHS, that's it. You don't have to bother about anything now. So just take it in the RHS, minus 1 by x greater than equal to 0. That's okay. Now you can just take the LCM and simplify. LCM of these two will be what? X square only. Now what will you get over here? 2 minus, this will be, you see, x, right or not? Because x square by x is x only multiplied to the numerator, greater than equal to 0. Now you know that in order to solve it, coefficient of x must be positive every time. So what will I do? Maybe I'll write it. Minus 1 you can take as common. So x minus 2 upon x square, that is greater than equal to 0. In order to remove this negative sign, multiply by minus 1 on both the sides. Inequality will change. So that is x minus 2 upon x square less than is equal to 0. Now plot the zeros of these polynomials on the number line. 0 of this polynomial is 0, 0 of this polynomial is 2. So 0, 2 over here. Now I can easily start with positive sign because coefficient of x is positive in both the cases. Now this is the 0 of this polynomial having odd exponent, so sign will change from plus to minus, right? And this is the 0 of this polynomial having even exponent. So sign will not change. From minus to minus only it will remain. Now you see, so this region is the solution, but make sure that you cannot use 0 because x is equal to 0 can't be there. It will make the denominator 0 and you know division by 0 is not possible. Correct? So you have to exclude this. So I can break the inequality basically from minus infinity to 0, open interval, union, open interval 0 to 2. 2 can be included, right? 0 of the numerator can be included, no problem. So this is the solution set. I hope that is clear, guys. So these are some of the cases, and obviously, I mean, if they include more, more functions in it, it will make it way more complex as well. But in this session, my point was to explain the wavy curve method to you. I hope it is clear to every student watching it. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever is being discussed in these sessions, not in these sessions, in the live sessions, you can get the PDF of those sessions. Also check for all the solutions, guys. It might happen that at one place or something, I must have done any mistake in plus and minus, but I don't think I did that. I hope it's clear, guys. Bye-bye. Take care, everybody.